Hi everyone, this is an explanation video of our data science assignment on question number 6, where the question is define overfitting and underfitting in the context of machine learning models. Describe how these issues can be identified and list strategies to prevent this, mitigate them. Now we will see model overfitting and underfitting. Where this introduction is model fitting means learning patterns from data to predict outcomes, where good fit generalized as well as a new unseen data. And what is overfitting? Where overfitting model learns noise and details specific to training data, failing to recognize to generalize. Very high accuracy on training data, poor performance on test real world data, caused by overall complex models or too many features. Overfitting is basically when we give the raw data to the model, then it learns detailed and minute patterns on that data, raw data. That's why it is able to predict perfectly on the given data but not on the new data, because of it learns too many noise from the training data. And what is underfitting? Model is too simple to capture useful patterns in the data. Poor accuracy on the both training and testing data can be caused by too few features, overly simplistic algorithm, or insufficient training. And what is different between them, overfitting versus underfitting, is where overfitting validation is have high loss, but in uh, underfitting the training data goes for early stopping. Now symptoms and identification, where we comparing training and test accuracy. Overfitting high train and low test accuracy. Underfitting low accuracy everywhere. And validation curves, learning curves, cross validation help spot these issues. Common causes are overfitting too complex models, too many features, small training data, training too long. And underfitting is model too simple, not enough features to predict the right output. Now preventing overfitting using cross validation techniques, applying regularization or like L1 L2, and early stopping and training, prone unnecessarily features on or trees, increase training data size, simplify your model, that it can prevent overfitting. While preventing underfitting, choose appropriate complex enough model, include relevant features, increase training time, as well as tune model hyperparameters. Hyperparameters are the parameters that are given to a model before testing. Reduce feature selection too aggressively. Where in practical example, medical diagnosis, overfitting may miss real cancer causes in test, and underfitting may miss all patterns, balancing enough complexity to capture disease signals but not memorize noise. Thank you everyone. That's all for our question 6.